And this is the last lesson in the rational functions unit. We're going to continue with what we left off with yesterday, adding and subtracting rational expressions. We're going to examine some of the more challenging ones. And our objective yesterday was to create common denominators. That's what we need when we add and subtract. To do that, we got to figure what we can make them all into. So in this case, we can make them all into x cubes. I can do that by multiplying the bottom by x squared. Whenever we do the bottom, we got to do the top. Multiply this one by x, and that one's okay. Collecting like terms on top, which in this case we don't have, and then we would simplify if we can. Now this one looks like a complex trinomial. So if we tried man plus, we quickly find out there's nothing that can really simplify in this one. Okay, restrictions, we only have one, x can't be 0 in the bottom. And that's where we started yesterday. Try the next one. What can we make these both into? I look at that and I say I can make them both into 2x squared to y squareds. I can do that by multiplying the first one by a 2x squared. So I need to do the same thing to the top. That will give me 4x4. The second one needs a y squared attached to it. So if we do the same thing to the top, we'll get 3wy squared. If we collect, on top we get one single thing, and on the bottom we have our common denominator. We can't factor the top at all. It's not a difference of squares, there's no common factors. So let's just state our restrictions. In this case, both x and y can't be 0, otherwise they'd create the 0 on the bottom. Okay, let's try the next one. Here's where we're going to start involving some algebraic expressions on the bottom, more than just letters or numbers, combinations of such. The common denominator here has to have the parts and pieces from both separate denominators. Now I notice they both have an x minus 1 in them, but this one has two parts. So the first thing they have in common is the x minus 1, but the second expression has the extra piece. If it's going to be in common, it needs to be under both pieces. So my common denominator this time is x minus 1 and x plus 1. Whatever I do to the bottom, I got to do to the top. So the first fraction only had x minus 1, it needs the x plus 1. The second one is fine. I want to make a single fraction, so we're going to expand 2x plus 2. And here we're going to expand negative x minus 2 into my common denominator. And then we're going to collect. On top, we'll get x, and that's it. And on the bottom, x minus 1 and x plus 1. Restrictions, x can't be 1 or negative 1, because both of those will make the bottom equal 0. Okay, the last question we ended off with yesterday, we found it might be easier to simplify expressions before we start rather than after we're finished. To do that, we often want to try factoring things if you can't see an obvious common denominator right off the bat. So if I look at the first one, I see that the first thing is made up of an x minus 3 and an x minus 3. The second one, however, is not in a good form to see if they have anything in common. So let's factor it. A simple trinomial. Now I notice that they have something in common already, and they each have something the other one's missing. The first one has an x minus 3 and an x minus 3, but it's missing the x plus 2. So whatever I add to the bottom, I got to add to the top. The second one had an x minus 3, the common piece. It had an x plus 2, but it was missing a second x minus 3. Now notice I put them in different orders on the bottom. The order is not really important. But whatever I do add to the bottom, I got to add to the top. Okay, my common denominator, and I'll pick one of the two orders, is that. And if I expand the top, distribute, I'll get x squared plus 2x plus x minus 3. Make sure to think of this as a positive 1, right? I'm going to collect those things as much as I possibly can. Oops, sorry, I managed to change pages there. And if I do that, we'll end up with x squared plus 3x minus 3 all over x minus 3, x minus 3, and x plus 2. The top cannot be simplified. It can't be factored. So as far as we can go, our restrictions are 3 and negative 2. Take the idea and see if you can try the next one. Right now, I can't see any common denominators. But if I factor a simple trinomial on the left, and I factor a different simple trinomial on the right, I notice that they have some of the same parts. But they also have some different parts. So whatever I put on the bottom, the extra piece, which in this case is x plus 5, I add to the top. If I do the next one, whatever I add to the bottom, I'm going to run a room here, x plus 5, x minus 3, and I was missing the x minus 4. I'm going to add that to the top. X minus 4. Okay, and now to expand. So on the top, we'll get negative 4x minus 20 plus 4x minus 16 all over x minus 3, x minus 4, x plus 5. We collect them up, and we'll get negative 36 over x minus 3, x minus 4, and x plus 5. And restrictions 3, 4, and negative 5. And we're done. Okay. Last one. Oh, last set, sorry. We got all kinds of parts and pieces in these ones. So, we gotta get them factored first before we can start. The left-hand side, what do I notice about that? I notice it has a common denominator, or sorry, common factor. The right-hand side, I notice it has a difference of squares. The left-hand side, I notice there's a simple trinomial. And now I can see all the parts and pieces that make up each of the denominators. I can now create a common denominator. My common denominator is going to involve all the parts and pieces from both. So I need to have a number 2, I need an x plus 2, a second x plus 2, and a x minus 2. To the first one, I've added this x minus 2. The next one, I need the 2, the x plus 2, the x minus 2, and a second x plus 2. So what have I added here? I've added both the 2 and the x plus 2, the second one, right? Okay, I want to simplify it. So I'm going to expand my top. And over here, I'm going to think of this as a negative 6, okay? That's what we're going to multiply in. So I'll get minus 6x minus 12 all over 2, x plus 2, x plus 2, x minus 2. Let's collect up the like terms. So negative 5x minus 14 over 2, x plus 2, x plus 2, x minus 2, and x cannot be negative 2 or 2. And lots of parts and pieces involved in that one. Yeah, let's go get the next one. Pause it, give it a try, see if you can figure it out yourself. If you're not so sure, check back in, see how you did. Okay, it's not ready to be solved yet because I can't see the parts and pieces. I'm going to factor the right side. Now I know some people are tempted to cancel these two things out, right? Same thing, top and bottom, but notice there's that plus sign in the middle there, right? So do not cancel. That would not be right. Okay. The right-hand side, x plus 2 and x minus 1. Okay. So what do I need? Well, they already have something in common. They have x minus 1. All I need is the x plus 2. This one is good. It's already got the parts and pieces it needs. I don't have to touch that one. The first one, however, was missing the x plus 2. Now I can expand and simplify. When I expand the first part, I'm going to have to FOIL. So x squared plus 2x plus 1x plus 2 plus x minus 1 all over x plus 1 and x plus 2. Let's collect up our like terms. We'll get x squared plus 4x plus 1 over x plus 1 and x plus 2. And x cannot be either negative 1 or negative 2. And that one was a little bit easier actually when we got to it. Okay, now we're ready for the last one. We'll put it all together, everything we've been doing. We've got dividing and adding and subtracting and multiplying and all kinds of stuff in this one. Can you do it? Where should we start? Well, BEDMAS says brackets, exponents, division, multiplication. So if I can take care of the division multiplication first, I can do that before I worry about adding and subtracting. To do division multiplication, however, I need to turn things into multiplying. So I need to factor. And when in doubt, we're going to factor it out, right? So a trinomial on top and a trinomial on bottom. Well, you might remember from dividing, we like to turn that into multiplying, but we have to write the reciprocal. Right? And the subtracting at the end, I'm going to leave it alone because BEDMAS says multiplying and dividing before adding and subtracting. So what can I do with this first section? Well, in this first section, it's all multiplying. So if I see the same things, top and bottom, I can cancel that one with that one, this one with this one. I'm left with just x plus 2 over x minus 2. The middle term is canceled. It's all gone now. So I've got just this question. That's a whole lot easier than we started with. How can I add those two things or subtract those two things together? Common denominator time. X minus 2 and x plus 3. And what did I add to the bottom? An x plus 3 minus 6 times x minus 2. Because my common denominator added the x minus 2, right? Okay, let's expand. FOIL. X squared plus 3x plus 2x plus 6 minus 6x plus 12. Think of that as a negative 6, don't forget. All over x minus 2 and x plus 3. Collect it up, we'll get x squared minus x plus 18 all over x minus 2 and x plus 3. And what can x not equal? It can't equal 2 and negative 3. And the tricky ones, because we actually did cancel something out way back when, these two back up here, right? 1 and negative 3. I think we already wrote down the negative 3 one. But we definitely didn't write down the 1. There's your restrictions. Okay, that's the end of our rational functions. Here's some questions to try. We'll do a review, and then we have our test coming up. Okay, we're going to have them all mixed together by the end of this unit.